Before moving on to the next example script, I want to use this one to demonstrate how errors or bugs in your scripts might sometimes show up. There are several kinds of potential errors. The simplest are syntax errors that the MaxScript compiler can point out immediately. For example, say I accidentally left out the word do in this inner for loop, like this. If I evaluate it, Control E, you see MaxScript prints out an error message in the listener and highlights. It says there is a syntax error. MaxScript was expecting the word do or collect following the range specification, but found an open parenthesis instead. Syntax errors like this are pretty self-explanatory and easy to fix. If you get such an error but don't know what the correct syntax is, you can see a complete summary of MaxScript syntax in the MaxScript grammar topic in the help file. It has syntax rules for every construct in MaxScript. Another kind of error is a runtime error, and these are also automatically detected by MaxScript. In this case, the syntax of the script is correct, but when you run it, it does something invalid while executing. For example, in this same loop, let's say I had started the index range at 0 instead of 1, like this. Okay, let's evaluate it. No syntax errors. Then let's run it. And bang, up comes this big error message in the listener, and the source window highlights the first line inside the loop. The actual error is described in the last line of the message, saying that a vertex index is out of range, and displaying 0 is the bad index. If you check the notes in the editable mesh topic in the help file, it says that vertex indices start at 1. So the problem is the I parameter given to the getVert function in the highlighted line. We incorrectly started it at 0. All this other stuff in the error message is meant to give you additional context information at the time the error was detected. It's called a stack trace, and it gives you a summary of the main dynamic code block nestings at the point of the error. The lines in red name the main active blocks. You can see the script was in the I loop, which was active in the F loop, which was active in the export mesh function. In a complex script with lots of functions and loops, this is helpful in telling you how the code got to the point of error. The blue lines in between, labeled with the word frame, list out the values of the local variables in those blocks at the time of the error. So, in the I loop, we can see that v and dv have yet to be defined, and that I does indeed have a 0 in it. The F loop is still at frame 1, and in the export mesh frame, we can see the file name and vert store, and so on. Looking at these locals for unexpected values often helps in figuring out what has gone wrong if it's not immediately obvious. Yet another kind of error is a logic error. These are errors in your script that cause it to not do what you want, but don't actually trigger anything invalid that MaxScript can detect. For example, say I accidentally wrote the number 1 instead of I as the vertex index argument to the getVert call, like this. When the script is run, there is no error detected by MaxScript, but the output is obviously wrong. All the vertex position information is the same for every vertex. Logic errors like this are often the toughest to find. You have to look over your code and try to figure what is going wrong. Sometimes it's useful to print out working values in the listener by inserting prints or formats temporarily into the code. Say in this case I suspected something wrong with the v, dv, or I variables in the loop, but couldn't see the problem. If I put this debugging print in here and run it again, all the values of I and v and dv for each iteration will be printed in the listener. There's a lot. I'll hold down the escape key to stop the script and look at the printout. The fact that all of the v's are the same might make me look more closely at the getVert call and notice the typo. You can use the escape key like I did to stop any script that is still running, though you may have to hold the key down for a second or so to get MaxScript's attention. One final trick you can sometimes use is to evaluate sub-expressions directly in the script editor to see what they do. I do this by selecting sub-expressions and hitting the number pad enter key, and its result will be shown in the listener. Now the tricky bit here is that this is always done in the global context, as though you just type that expression into the listener on its own. The rest of the code is not being run, and so none of the variables used in the code fragment are set up. What you have to do is simulate this by setting up some globals of the same names with test values in them. So, say I wanted to experiment with the getVert line. I would set up I and obj and origin in the listener something like this. And now I can test the code. Let's try the getVert call, highlight it, and hit numpad enter, and out prints the vertex coordinate. Now let's include the coordsys context, and out comes a relative vertex coordinate. I can change I, say, to 42, and try again, and see what different input values do. As I say, this is somewhat tricky to set up, but can help you understand what a piece of complex code is doing.